This is Tyler from the University of South Carolina, and this is our video poster entry for the square beam category for SAMPE 2018. The first step in our bridge building process was the design phase. We had to follow strict criteria set out by the National SAMPE Board. The goal of this project was to design and build a composite bridge that is 2 foot long and can withstand 9,000 pounds in a 3-point bend test while being as light as possible. Featured below is a 3D model of the 3-point bend fixture and a stress strain simulation of a square beam under a 3-point bend. Initially, our design featured a cross-sectional cutout that narrowed as it got closer to the center. Additionally, it also had foam inserts which would act as supports while under 3-point bend. These were later redacted in favor of a more simplistic design with the following layout strategy. While designing the tooling for the square beam, we came across the problem of the square beam becoming stuck to its mold after the curing process. To alleviate this, we created a foam mold that could be dissolved by pouring gasoline through the bridge after it is done curing. The first step in the manufacturing process was to cut the plies at the angles needed for the previously stated layup strategy. Then we took those plies and arranged them in stacking sequence in accordance to the layup strategy. We then mixed epoxy and hardener and began preparing for wet layup. After evenly coating each ply with epoxy resin, we then lay the mold onto the plies as we prepare to wrap the mold with the carbon fiber. As we continue to wrap the carbon fiber around the mold, we pause to ensure that no air bubbles or wrinkles are forming, while continuously adding more layers and more resin as we go. During the curing process, we applied a vacuum bag to remove air and voids. The picture to the right depicts the cross-sectional area of our square beam before gasoline is poured through, dissolving the foam. After the curing process, we can now take the square beam out of the vacuum bag and pour the gasoline to dissolve the foam. Now we have a finished product ready for testing. With every test, we learn something new and can adjust accordingly for the next manufacturing and testing cycle. The University of South Carolina Student Chapter would like to say thank you to Jamestown Distributors for assisting us with supplies. We would also like to extend a huge thank you to Hexcel for supplying us with the majority of our materials and providing guidance along the way. Finally, we would like to say thank you to the University of South Carolina and the McNair Center for Aerospace Research.